In this video, we're going to learn how to solve equations that, although they are not quadratic equations, they are in something called quadratic form, which means that we can use our methods from quadratic equations in order to solve them. And the method that we're going to use to change from a non-quadratic equation into a quadratic equation is something called U-Substitution, which you are actually going to use not only in this class but in many future math classes, because it turns out that it's a very common technique in math to take a new problem, something that you don't know how to handle, and convert it into something you've previously solved so that then you can finish up the problem. So converting problems into new ones is something that's very popular in mathematics, and one of the most common ways we do that is something called U-substitution. Now, it does not have to be U, it's just the letter that we commonly use. You can put whatever letter you want to, but the idea is we're going to change our variable. Now, if we look at our first equation here, it's x to the fourth minus 5x squared plus 4 equal to 0. And that is not a quadratic because it has x to the fourth in it. It's a fourth degree equation. Quadratics are only degree 2. However, I'm going to make a choice here. I'm going to choose u, my new variable, to be the same value as x squared. Well, if that's the case, then what would u squared be? Well, if you square x squared, you're going to get x to the fourth. And that means that this equation right here is going to become u squared minus 5u plus 4 equal to 0. And lo and behold, that equation u is a quadratic equation. And we know how to solve quadratic equations. The best way, if possible, is to factor. And this one would factor into u minus 1 times u minus 4. So then we break it apart like we do with normal quadratic equations. And we get two values of u. But you don't want to circle those they're not your answer, because in the original problem there was no u. So if you tell a person what u is, they're not going to know what you're talking about because there was no u there. So you need to tell them what x is, so you need to go backwards now. And we use the fact that u is the same thing as x squared. So then u being 1 is the same as x squared being 1. And u being 4 is the same as x squared being 4. And then we can use the square root method here. Remember, when you square root here, you have to put plus or minus. So the square root of 1, we get plus or minus 1 there. Square root of 4, plus or minus 2. And this then is the final answer to your problem. So again, we took our problem that was an equation involving x. We made our choice for a new variable u. We converted the problem to that new variable u. We got a quadratic equation. We solved that. And then once we've solved that, we convert our answers back to the original variable x. Now things worked out just fine here because I knew what to pick for my u, and it's all going to work out nicely here. But I will warn you that knowing the correct choice for what u is like, I don't know, 80% of the problem. If you make the right choice for u, then your equation in terms of u is going to be really simple. You can solve it no problem. Whereas if you make the wrong choice for u, the whole problem might fall apart. The good thing is that the problems we usually see in a section like this are fairly straightforward to figure out what u is. But as you go further and further in mathematics, it ends up getting harder and harder to pick what the u may be. So I just warn you that if you're having trouble with picking the u, that's understandable. And the only way to get better at it is to practice it, to see more examples until you can find out the pattern that works best for you to identify the u. Now in this next one here, I want to make it equal to 0 first, so I'll move things over. And then my choice for u here is going to be the x cubed term. And if you were to square that, you'd get x to the 6. And I want to say I'm somewhat cheating here, because I know if I pick this to be u, this better be my u squared. If it's not, then this method really wouldn't work. Right? We need to be able to have a u and a u squared there. So my equation u would be u squared minus 7u minus 8 equal to 0. I can then factor that, u minus 8, u plus 1. I get two values for u, positive 8 and negative 1. Then I go back to what x was. Well, u is in fact x cubed. So I'd have x cubed is 8 and x cubed is negative 1. And this time, instead of square rooting both sides, I'm going to cube root both sides. And remember, when you're doing a square root or an even root, you put plus or minus. But when you're doing an odd root, you don't have to. And so therefore, we get x is 2 and x is negative 1. For the next one, it looks like a big mess, but what we can do is we can just take this whole thing here, 3x minus 2, and that's what our u is going to be. And by choosing that as the value of u, the problem becomes much simpler. U squared minus u minus 6 equal to 0. Right? U squared minus u minus 6 equal to 0. I will say, we could have avoided this. We didn't have to use u sub. We could have just taken this whole thing, multiplied it out, combined like terms, and it would be a true quadratic equation already. But this way is going to be a little bit easier to handle. Okay, so then we factor u minus 3, u plus 2. That gives me u is equal to 3 and u is equal to negative 2. And then once we've got our u values, we go back to x. U is 3x minus 2 is 3, and 3x minus 2 is negative 2. This gives me a 3x is 5, or x is 5/3, and a 3x is 0, or an x is 0. So 5/3 and 0 are our two solutions here. And then the last problem, this one is not even a polynomial equation. It's a radical equation. We got that square root there. And you most certainly could solve this using the techniques on radical equations, squaring both sides and all that stuff here. But instead, in this section, we are going to use a u sub, because that's what we're talking about right now. And the thing we're going to pick for a u is going to be square root of x, because if you square root of x, it just gives you back to x. So that means we end up getting here u squared plus 3u is 4. And we can go ahead and subtract the 4. We can go ahead and factor this. We get our two values for u there. And then what is our square? U is square root of x. And then normally when we have a square root equals, we square both sides to solve it. However, before I do that in this first one, this says that square root of x is negative 4. It's not actually possible for the square root to be a negative number, which means that should just go away. That's not going to give us any answers. But in the second one, we can square it, and we get the single only solution is going to be x equal to 1. So again, this U-Substitution method, in this section, we're just starting to learn it here. Usually the u is going to be somewhat obvious. Generally, it's going to be the middle term, and you have your three-term problem here. You want a u somewhere in the middle. All right, that's generally where it's going to end up becoming here. But regardless, the more practice you get at it, the better you'll be at picking u. And then ideally, once you've picked your u and changed things over, it should be significantly easier to work out.